Hi viewers, welcome to LMS Solution. Today we are going to see about MATLAB simulation of sliding mode control strategy of dynamic voltage restorer. So first you have to discuss about what is dynamic voltage restorer. For example, you consider this a distribution feeder. This is the distribution feeder having two lines. One line is connected with the domestic load and another line is connected with the sensitivity load like computer and server. For example, any fault occur in the distribution feeder. For example, the fault will be occur in this line. Because of this fault, what will be happen? The voltage sag will be occur in the distribution feeder. So when voltage sag will be occur in the distribution feeder, what it going to affect these sensitivity loads. So we need to maintain the distribution feeder voltage always 1 per unit because we need to protect that sensitivity load. In order to protect that sensitivity load, because during the fault the sag will be occur for the fraction of seconds. During that time we need to maintain load voltage at sensitive load at 1 per unit. So for the purpose we have to use powertronics device to mitigate this problem. So here we are going to use a DVR, nothing but a dynamic voltage restorer. So this DVR consists of DC energy source and IGBT converter. So here we need to measure that the distribution feeder voltage, and then based upon the distribution feeder voltage, this DVR going to be supplies inject some voltage to the system in order to maintain the load voltage at 1 per unit the sensitivity load. So this is the use of this dynamic voltage restorer. See, now we are going to see about how we can implement this DVR in the MATLAB, and also you have to discuss about sliding mode controlling system. This the system is implemented for this explaining about dynamic voltage restorer. Here you can see here we have two kind of load as like in the distribution feeder. So this is nothing but normal domestic load or nonlinear load, and then you can see here this is known as we are going to consider as sensitivity load. So this is known as normal load or unbalanced load. This is known as sensitivity load. So we need to protect this sensitive load during the voltage sag. That means we need to maintain voltage at 1 per unit during voltage sag because of this fault. Here we are created that fault. So what happened because of this fault, grid voltage have sag. So we need to mitigate that problem. Further, we have to install DVF here. DVR is one kind of series filter. So this is DVR, and then here we need to measure load voltage. That means this one. Here we need to measure the load voltage. Load voltage is given to this DVR control, and also this series filter having DC source, and this is the source. It is having voltage of 415 and 50 Hz, and then we need to measure the load voltage from here, and it's given to DVR control. Inside you can go here. Here first we need to convert it into per unit. So we have to measure that voltage, and then in this process via filter, and then going to divide with the 415. So that means we are converting it into per unit value. And then here we have ABC quantity. In order to control the system simply or easy manner, we need to convert that ABC quantity into DQ naught. Further, we are using here ABC to DQ naught conversion. And then here you need to control only two data. One is direct axis data and quadratic axis data. That means just you have to take only VD and VQ voltage. VD is going to be compared with the reference voltage, and then VQ going to be compared with the 0. And then after comparison, here we are going to done that comparison. So after that you have to process via sliding mode control. Inside you can see that this is a sliding mode control we are used here in order to control that that mean VD voltage and VQ voltage. The same kind of sliding mode control used in the VQ side also. After that we are getting that control voltage here. So next you have to convert we are going to convert that controlled DQ not voltage into ABC. Here we are going to combine that one DQ not to, then mean this combined here, and then here we have DQ not, and then it going to be converted into actual ABC by using this conversion. So this is nothing but a DQ not to ABC conversion. So after here we are having only that controls that should be converted into actual, multiplied with 415 volt. After that you have to convert this controlled reference. Here we are comparing that controlled reference voltage with the load voltage, and process via Hysteresis controller to generate the pulse for that series filter. So here we have that pulse. That pulse going to be given to this series filter based upon this load voltage. Whenever the voltage sag occur in the system, this will be generate the or inject the voltage into the system in order to maintain this voltage always at 1 per unit. So this is a concept. So next you can see here the fault will be occurring the 0.1 to 0.3 seconds, and also we generate some harmonics in 0.4 to 0.5. We can check the performance of the system during fault as well as harmonics. Here we are measuring that the grid voltage, load voltage and injected voltage. We have to check the details here. Now I'm going to simulate this model. This is grid voltage, this is load voltage, and then this injected voltage in the distribution feeder in the sensitivity load area. After 0.1 second fault will be occur, we can see the variation in the grid voltage and load voltage. Now you can see that because of that fault what happened, that means we are having voltage sag in the system with the two phases. But you can see here that load voltage is maintained at 1 per unit because of that DVR. DVR is injecting some voltage to maintain the load always 1 per unit from 0.1 second to 0.3 seconds. And the DVR effectively control that the voltage sag or mitigate the voltage sag in the load side because of this fault. You can check out after 0.3 second the fault will be removed from the system. Okay, we can see the response of the system after removing that fault. During that time you can see the grid voltage, load voltage and injected voltage from the DVR. Here you can see the system is restored because of that grid voltage maintained at 1 per unit as well as load voltage maintained at 1 per unit. Now you can see that DVR is not working now. After 0.4 second we are injecting some harmonic in the grid voltage. So we need to check the response of the system whether load voltage maintained at 1 per unit or not because of the harmonics. So now we can see that the harmonic injected in the grid because of that grid voltage is not sinusoidal, but you can see that load voltage is maintained at 1 per unit because the DVR injecting that harmonic voltage opposite to the that grid voltage. So that's why that load is maintained at 1 per unit always. So this is the performance of the dynamic voltage restorer with the sliding mode control. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much.